not really well focused with me in chapter 2, get ready, please write the outline. How about we try to take some notes, unless you believe those files are enough? Okay, so if you believe this whiteboard is enough, no need to take notes. And if you believe you need to take notes, Miss Jessie is not gonna write a lot. It's gonna be a summary of the main ideas, okay? So, yeah, please go get your copybooks. The teacher is not there. Tabrin, what class do you have? Arabic? French? Stay, maybe she has internet connection issues. All right, so Reem is gonna disturb us every minute. It's okay, we love Reem, don't we? Yes, she's my little one. She's in grade 2 and she's all over the place. Every time she needs something, she comes and hugs my leg for you not to see her. And I freak out every time she does this. And she comes to you every time she needs something and you're doing a quiz, for example. Yeah, it's okay. Make her public and then it will never be a worst time ever. Like, say her name publicly. Like, let her be on the camera. Yeah. شو اسمها? Masa, she's now next to you. Not yet. Hello, Masa. You need to have your camera on. Hello. I'm Jessie. All right, so back to Ivan. You're good? Ready? Yalla, define kinematics quantities. By the way, I don't know if we ever discussed the difference between kinematics and versus dynamics. What's the difference? I know kinematics is an ugly, a very heavy word. What is kinematics? Kinematics. I think Shadbel knows. And dynamics? Yeah, but the dynamics is the study of motion as well. So let me just state the difference, because if you know the difference, it's all about topic 2.1, because 2.2 is dynamics, if I'm not wrong. So kinematics, you describe the motion and that's it. So how am I moving? For dynamics, you discuss the reason of the motion, which is why am I moving, all right? Why am I saying that? Because now in a moment, I'm gonna ask you, what do I need to describe my motion? So if you know it's about description, you would know what are the quantities I need to talk about. So again, my arm is moving. Can you please describe the how? Okay, up, down. So okay, circular, I would say up, down, or a direction. What else? So I would say circular is yeah, angular speed or momentum. I can think acceleration. I can discuss the time and all this, you know? So for my, okay, so the why could be muscles, could be force, could be torque, and whatever, okay? So back to my grade 10 students, when you did physics in grade 9, you did a lot of forces. You never did speed, right? But you did speed in grade 8. So you did a lot of kinematics in grade 8 and a lot of dynamics in grade 9. This is what you did. All right, so now we're gonna go back to kinematics of grade 8 and then topic 2.2, dynamics of grade 9 along with vectors. So it's gonna be more mathematically advanced. So far, the quantities I'm talking about are gonna be easy ones, not those that we just listed, quantities. I want you to be clear about distance. So the distance covered. We need to discuss displacement covered because there's a small this difference. The time taken, we need to discuss speed and velocity. There's a tiny difference as well. We need to discuss acceleration. We need to discuss, and that's it. Okay? So how about, yeah. Okay, a torque is a force related to the distance away from the rotation. Look at my arm. No, it's a distance force. I want you to look at my arm. You see, this is the pivot point. Okay? All right, back to, I say pivot, but you can say pivot. So I will apply a force at this position or apply a force at this position. So imagine this is a door viewed from above. It will be easier for you. If this is the doorknob, it will give you a certain torque. But if I apply the force on the wrist, it's gonna be a different torque, you know? So the torque is not only the force, it's also how far away from the pivot or the pivot, okay? The greater the torque, and therefore the greater the torque, and therefore the greater the rotation, the faster it is. Yeah, Newton dot meters, so force times distance. Yeah. Yes, you hear it, Enko. Yeah. 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 All right, since I said define, I don't want to move to something new. How about we define? So, but I don't want to define each term. So what's the difference between distance and displacement? Can you guess? And I want to hear everyone, like Tony, Ivan, just throw, yeah, maybe you're right, maybe you're wrong, it doesn't matter, we're just discussing stuff. What's the difference between distance and displacement? I think Tony knows. Do you remember, Tony, the example of you taking your car, actually stealing your dad's car, going to see your girlfriend? شو توني؟ تتذكر؟ Ivan, you remember the example? Maybe I must draw. I must draw Tony stealing the car. So this is the car. Okay, Akid, it was raining the day before, so you can see the position of the car because it's dry underneath. So Tony went on a trip that is, I don't know, like 10 kilometers long. And he came back and he put the car exactly where it was. What is his displacement? Exactly, his displacement is 0, although the distance covered is 10 kilometers. Okay, so maybe we can say the distance. So the distance covered is how far Tony would go, but the displacement is only the resultant vector. I mean the difference between the initial and the final point. Okay. It's gonna be the sum of all the displacements. Yes, I think I'm gonna fit. But the distance is not a vector, so I would say that the displacement, the total displacement, is the sum of the tiny displacements. Okay. I hate this. Okay, maybe take a screenshot of it so I can move it with Tony. Okay, I'm sorry for this mess. I'm gonna write in tables because I can control tables in a better way. All right, anyway, we're done with distance and displacement. I want you now to try to come up with speed. How do you define speed and velocity? And then for me not to forget, I want to do average speed because you will see a lot of questions about average speed and average velocity. Okay, so what's the difference between speed and velocity? And how do you define them? Anyone? Yes, but may I please speak to Shadi? He wants to say something. And then the floor is yours, Wissam. Okay, I like this. You wanted to ask something, Wissam. Okay. Okay, this is a very interesting problem. Maybe we should name it as Wissam's track problem, and maybe we can put some values and solve it. All right, I'm gonna do that, but give me a few minutes. So yes, Shadi, you said speed is equal to distance over time, although you said that the velocity is displacement. Velocity is displacement over time. And I can say that speed is a scalar quantity. You agree? By the way, I promised myself to show you the quiz. I will in a moment. I mean the answer sheet. And the velocity is a vector quantity. When I finish item 1, I'm gonna go to the quiz. I want to show you a few things. All right. So we did not discuss units. The SI units for distance and displacement is, what's the SI unit? Meters. Okay, I want to hear more of Ivan and Sherbel and Kirill. Okay. All right, speed and velocity SI units. Yeah. Okay, so it's gonna be meter dot second to the -1. If you hate it, meter per second is not wrong, but try to get used to writing it as meter dot second to the -1, because this is how it's gonna be in your book. So this means meters per second. Okay, Shadi, you already asked me about this previously. Okay. Yeah, I know it is superscript, but I thought, okay, so like that. All right, so now, so speed and velocity, this is basically the idea, but how about we discuss average speed? Because every time they ask you average speed, and I remember I did an example with Sherbel. Do you remember you on the bike? You left your home in Mansouriye, and then you went down to Mkellis, and then you ate bouza, and then you went to Jbeir. Sherbel, do you remember the trip? Look, up. So Tony, you remember Sherbel going on a trip, but Sherbel cannot remember himself going on a trip. And the question was, find the average speed. Because we did that at the end of the school year. So my grade 10 know all of this, right? Because we did them already, yes. Okay, so average speed, we don't do V1 plus V2 plus V3 over 3. When they ever ask you about average speed, you have to calculate total distance over total time divided by total time. This is very important. So even if you are given the speed, and this tells me back about Wissam's track problem, if I need to go back to his problem, I cannot take the speed. I need to find the distance and the time and eventually compute the speed. And I assume average velocity is going to be what, Kirill? Yeah, and which would be 0 in the case you're going on a track. I mean by track, a loop. Displacement, I missed the track. I fell on my back and I'm not running since Tuesday. I'm very upset. I don't care actually, to be honest, but I don't know how to heal myself. I think I need to go have an x-ray. Oh, do you think I would be okay? All right, let's forget about this. Describe 2 types of motion. I think we're done. Before I attack Wissam's problem, let me show you my answer sheet to the quiz that I'm gonna post on under the quiz itself. I took a picture of it this morning, just a picture. I wonder why my phone gives me HEIC. Okay, it's here. Let me turn it so you can see it. And let me show you. All right, so basically, I saw this answer on many of your answer sheets. By the way, I did the same mistake Wissam did in here, and some other student did as well. I did not see the minus initially. I did not erase with an eraser. I wanted you to see that I did a mistake. By the way, Kifah and Leo would be listening to us tomorrow. We're recording this session, that's cool. So that's why I want to show the answer sheet. So you see that I simply broke down the vectors into components. I added all the x together, all the y together in one shot, or theta angle. Very easy. I was lucky with x and y being positive. Otherwise, the angle would be a little bit tricky. I was very happy with Ivan's solution. Ivan, you did it all right, but you did not show the minuses. And obviously, your x and y turned out to be wrong. If I'm not mistaken, it was Ivan. Otherwise, you would have took a full grade. So Ivan, I'm not saying you did bad, even if your grade showed to be bad, and it's out of 9. If you lose like 2 points, it's gonna be a disaster. Now for the graphical method, yeah. 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 Okay. Okay, so what Wissam is trying to say, if we take the angle from the x-axis, it will turn out to be negative without us doing the thinking. But what can I say? It's okay to think as well. So, and all I'm doing is trying to avoid many methods. I don't know. So concerning the graphical method, all the students who did tip to tail got something very close. Ivan, you were not happy because you did not get the same answer. It's due to the fact that you have a mistake in here. And let me say it was a tiny mistake. Yeah. Yeah, yeah. Okay, somebody else, not Ivan, maybe did this wrong and this right. And maybe, I don't know, Shadi, you have a mistake? No, Shadi did well. I don't know, but but what was your mistake? What's wrong about it? Oh, there's some student, that's Shadi. Shadi did x1 plus x2. Then the answer he added to x3. Then the answer he added to x4. It was crazy. Just add them up. Shadi, انت على طول you try to find difficulty in your life. You make it. Oh, anyway. Oh, okay, it could be. All right, anyway, I cheated for this one. By the way, you can simply cheat knowing the answer. You can try. But the cheating I did is not because I know the answer, because you see there's a slight difference between my graphical. By the way, you will always have a slight difference. A graphical method is an estimation. The scale I've chosen is not super cool. I should have chosen 100 newtons to be 2 centimeters because it would make my graph look bigger, and bigger means more precise. The thing I did as cheating, I don't want to use a protractor. I'm not sure I have one at home actually. So instead of drawing 60 degrees, I drew the X and the Y component. Do you see the small dotted lines? So I did 1.5 centimeter and 2.6 centimeters, and then I joined because I was too lazy to find a protractor and to measure 60 degrees. So I was using the components, and I don't see why not, because this makes it more precise. Anyway, for the answers, maybe I want to find and discuss quickly. I think feedback is very important. So even if this would take us some time, I'm sorry for that. Hedy, you're very quiet. Yalla, I need 1 second. I will be back. I'm sorry. طب يلا معك حق. Screenshot. Done. Okay, so which of the following contains three scalar quantities? Mass is scalar, charge scalar, speed scalar. Weight is not. Weight is the force of gravity. Everything else is scalar. Okay, so and here three vector quantities. Energy cannot be a vector because I wanted to pick C initially because of field strength. Energy, there is no way energy would be a vector. I even Googled if there's a way, a definition of an energy vector. It does not exist. Mass is not, weight is. So field strength should have been written as field, and let me put this away. And I went back to the IB official question to see if I was wrong, and they picked A to be the answer, and it's written field strength. Field strength is a scalar. I don't know why they did this terrible mistake, so I'm sorry for the confusion. It has to be field, because field strength is only the strength of it, the magnitude. All right, anyway, I will put this away, and if you have a question about it, I can come back to it, okay? So far what we're doing, I assume everybody in my classroom know a little bit of this from middle school somehow. My grade 10 know a lot of this because they did this chapter at the end of the school year, maybe in a different approach. Okay, now Wissam's track problem. Okay, so Wissam, I'm gonna create a table to put some given in it, okay? So yeah, actually we did not state his problem yet. So the first loop, all right, on the track. By the way, the track is 400 meters long, okay? So I'm gonna say the distance covered, distance 1 is 400 meters, okay? Yeah, okay. Second loop is also 400 meters. We need to put values because trust me, life will be easier with values. So it's also 400 meters. Let's say he did the first one 4 minutes in 1.5 minutes. This is usually a good running time. Not too fast, not too slow, but fast enough. You want your second loop to be faster? So what was your question? Okay, so you have V1, you want your V2 to be twice V1. Okay, and the question is how fast or how much time, this is the question, right? So the, okay, so you want V, which is the average of the whole thing. Okay, okay. Okay, so the question is, how fast should I go? All right, it sounds like not so difficult question because you have the same distance. All right, so for me, how do I solve this? Anybody has some ideas? Maybe give you some time to think about it. Don't do this, don't do this. So people, don't do like Kirill. Did you hear Kirill? Everyone, don't be Kirill, okay? Don't do like Kirill. Ivan wanted to say something a few minutes ago. بالك كنت عم بتقول شيء, you were asking something about the loop, right? It was a question. Okay, Hadi, where are you? Hadi? Yeah. Okay, so I'm gonna start from the definition and maybe pick a pen because I like pen. V, isn't it total distance over total time? Right? Okay, so I changed my mind for the pen, that's too slow. So I'm gonna say V is equal to total distance over total time. But by the way, we're doing speed, no displacement in here. Total time. All right, total distance. Do I know anything about it? Isn't it 400 plus 400, which is 800? Yeah. Now total time is the one that I don't know. It has to be T1 plus T2. Okay, no problem, which means how many seconds is this? I want SI units. 90 seconds, bravo, Alec. Makes so much sense. Okay, so it's gonna be 90 seconds plus T2. And I'm gonna keep it as such. Now I'm gonna take this equation, replace, all right, let me show you. I'm gonna write V is equal to big D over big time, okay? I'm gonna replace V by 2V1, and this one is gonna be replaced by 800. Like have an equation, I will fill in what I know and solve for the unknown. This is 90 plus T2, okay? Okay. Now T2, I want to replace it with something. Isn't V2 equals distance 2 over T2, which is 400 divided by T2? Yeah? Okay, which means T2 is 400 over V2. So this is 400 over V2. Okay, so 400 over V2. Yeah, my camera is frozen. I don't know if you can see me. I just hope you can see my screen. So 400 over V2. Now I want to get rid of V1. I think I know V1. V1 is known, isn't it? So over 90, yeah, over 90. Okay, now my equation, if I simplify it, I only have one unknown, which is V2. And that's the question mark, isn't it? So I started from a general equation that is total V is total distance over total time. I plugged in everything I knew, and I keep on plugging in what I know until I end up with one final answer, like one final equation. Now let me simplify this equation. It's gonna be 2 times this, so 800 over 90. Okay. How do you know you just did it? Common sense. Oh, okay. Okay. So this is gonna be 90 plus 400 over V2. I'm just writing it for it to look better. Now I want you please to take your time and do the calculation. Everybody in this class should be able to. Simply, you do cross multiplication. This times this, it has to be like a big parenthesis. You need to, I'm thinking, do you get a quadratic equation? I don't know. Take some time to do the calculation. V and T. Yeah, if you keep D1 and D2, I think it's gonna be better because they cancel out and it's obvious. So this would go and this would go. You would have one instead. Okay. Take a moment to do it. Which means 90 equals 90 plus this, and this sounds so awesome because you will have, oops, which means V2, I just got 0 for something that shouldn't be 0. Do I have a mistake somewhere? Let me check. T2, yeah, 0 for this fraction, but there's something wrong, which means it's impossible. Oh, which means no matter how fast I can go, there's no way my final average. Wow, did you know the answer or you just realized? I love, yeah, it would be obvious. Yeah. Yeah, 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 yeah. I love this problem. Thank you so much, Wissam. And it's great job, Kirill and Wissam. Let's, yeah, but you got it. Yeah. All right. So let me write a conclusion for Leo and Kifah. We can say no matter how fast you can go, even at the speed of light, you will never be able to achieve a final average, a total average speed. Let me call it total. A total average speed to be 2 times v. All right, v1. Awesome. So we just had a nice application. How can you? I think so maybe those equations are no more applicable. Maybe you're right, because v equal distance, total distance over total time is going to change. But let me check. Am I still in item 1? Define kinematics quantities. I think we did not define time well. And the frame a little. So let me talk a little bit about time. How do you define time? And how do you measure it? Like if I'm doing an experiment and I have a watch, it's so sad that you cannot see me. Wait, let me try to put my camera on and off, because I know my internet connection is okay. Can you see me now? Yes, so it was just frozen. It was not internet connection. All right, so you see my watch, I cannot use that to measure the time, or maybe I should use it indirectly. How do you define time in a kinematics problem? Anybody else would want to try? No? Okay. No, that was not my question. I don't want you to define the second. I want you to define the quantity time. In an experiment, yeah, how do you measure it? All right. Okay, Wissam, this is the definition of a constant reference. I totally agree, and it's really awesome. But my question was different. I was just saying you're doing an experiment and you need to time this experiment. How do you do it? What is the procedure to do it? You don't go and measure the time between the spin of the electrons and use it in your experiment. You're timing your little sister. She's, I don't know, she's crawling on the floor. How do you time her? That's my question. What do you use as a measuring tool? Okay, stopwatch, and it's very important. So you need a stopwatch and you need an origin of time. What do you mean by origin of time? Okay, so time zero has to be defined. This is all I wanted to stress on. So you need a stopwatch and you need to define when time zero started. Okay, and I'm gonna call this the time axis, and you can only move forward, okay, on the time axis. And this is what I really care about, the time axis, because very soon we're gonna start. Oops, the session is over. Okay. You can only move forward on the time axis. T equals to -2 seconds does not mean moving backward, means 2 seconds before time zero. And this can happen because time zero can be anything. If now is time zero, I'm gonna say at -10 seconds, we've been writing this, okay? So I'm gonna stop here, save the file. I love mechanics, don't you? This is so interesting. Wait and see the problems. They're not difficult. They're so nice to do. By the way, the Suvat will change your life. I'm gonna do item 2 tomorrow very quickly so we can start so that it's gonna be fun and easy fun. Okay, I'm gonna leave you. You too.